Hello, everybody. I'm talking in English. I hope that's okay. I actually live here a few kilometers away in OSGi, but my, let's say, skills in presenting in Greek are limited, so I do it in English. So it's my pleasure to introduce you the OSGi Alliance and the standardization activities that we are doing in the Internet of Things. Let me see. Okay, so just a little bit of background. Who is the OSGi Alliance? OSGi Alliance was founded in 1999 by a couple of companies like IBM, Ericsson, Motorola, Nokia, I think also, with a mission to define specifications for connected devices, which we would call today the Internet of Things. So we had a particular interest in the smart home, and it took us a while and a long journey to actually achieve something in this domain. But in the meantime, OSGi has emerged a lot. So it's today a proven mature software architecture. There's actually a middleware and a framework that's based on Java, and that basically defines a modular architecture. So it's available in different implementations as open source or even as, let's say, a commercial implementation. It's being used in many different environments, so the framework itself is so generic that it's being used in embedded devices such as a home gateway, such as a car telematics system, or an IoT gateway, but it's also being used in enterprise desktop server cloud systems. So just to give you a few examples, those of you who develop software and use the Eclipse development environment, that's OSGi based. So there are like, I don't know, 50 million developers using this, and this plugin mechanism is exactly what OSGi provides. Then there are a lot of products from companies like IBM, Adobe, and so on that are basically also based on OSGi. So all the Java enterprise application servers have an OSGi core. OSGi has a very transparent development process. That means that everybody, being a member or not, can review what we are working on. So we have a GitHub repository where we have all our documents in their most actual states, so you can see where we are with our requirements and where we are with our actual design documents. OSGi is all about strategic partnerships and collaboration with other organizations. IoT is so huge that nobody can do it alone, that we believe in. So we had, especially in the smart home domain, a very good collaboration with the Home Gateway Initiative. We just launched a new collaboration with the Industrial Internet Consortium, and we are also in talks currently with 1M2M to do common standardization work. So OSGi provides a global ecosystem. There are lots of developers on the market that basically use OSGi. There are lots of tools. There are lots of available implementations, as I said. So there's a lot to start working on. Since we introduce let's say, a more complex way of implementing software, we also provide best practices on how to do that. And OSGi has a lot of industry and end user adoption in different domains. I will tell a little bit about in a while. So this is just an overview of the members of the OSGi Alliance. So these are mainly the strategic members, the ones that actually pay the biggest member fee. So we have, lots of software companies, big software companies there, like IBM, like Oracle, Software AG. We have Process, the company that I'm working for, Deutsche Telekom, and so on. So why do we think that people should care about OSGi? So especially, if you consider the developments in the smart home market, where we now see a development from feature limited devices, yeah, just as a thermostat, for example, that connects to a tablet to be, let's say, monitored or controlled. We are now moving from those devices to actual smart home ecosystems. That is, you can see this driven especially by telecommunication operators like AT&T and Deutsche Telekom, and they actually, want to be able to, very fine-grained manage such an environment. So you want to provide an environment where, third parties can deploy new software modules. You want to provide an environment where you, can secure applications from each other and such things. And OSGi is doing this. So it's a modular software architecture that follows the principles of service-oriented architectures. We define the execution environment, a Java-based execution environment with many different APIs. A few of them I will introduce in the following slide. We have a common architecture that is applicable to all the environments, as I mentioned before. So I already said, so lifecycle management is a crucial topic. So we provide a standardized way of managing an OSGi environment remotely. As I said, to deploy software functionalities, to remove functionalities, to update them, to monitor the environment and such things. And of course, OSGi, as it is modular, is all about reusing portable software components. I mean, you as an application developer don't want to necessarily limit your application to one ecosystem. So you want to be able to, sell basically the same application for, let's say, heating management, not just to Deutsche Telekom. You also want to sell it to AT&T, and OSGi basically, provides the environment to do this. So it's all about decreasing development and maintenance costs. This is what service-oriented architectures do. So they basically are able to manage the dependencies between software components, and you, as I said, you can just update a single functionality of the overall application. This is reducing time to market and enables a more agile process. As I mentioned, so OSGi has been active for many years in IoT. Also, we never really called it that way until a few years ago. So in 2012, we had a specification for residential gateways. This was in collaboration with the Home Gateway Initiative, and so we. First specification basically was all about how to manage an OSGi environment, so remotely in a telco infrastructure. So we basically defined a TR69 connector service specification. So TR69 is like the standard protocol today for managing firmware updates in routers that you have at your home, and we basically applied the same technology for software modules. We have a so-called device management tree that is based on the Open Mobile Alliance device management specification, which is basically another protocol, but in the mobile domain. So last year we launched a new specification that deals mostly with how to connect sensors, devices, and assets in the home. So we have a standardized API for N-Ocean to discover and control N-Ocean devices. N-Ocean is one of the many wireless protocols that you can use in smart home. We have a USB device category specification that is, let's say, especially for routers where you have like extensions, USB extensions, to integrate new protocols. You need to be able to recognize this, and this is what it's done for. We have a serial device service specification, so that we have a standardized way of dealing with a serial port. And in the Java world, this is actually a big issue, because there are many different ways of doing this, and none are really standardized, and we basically can serve them all. Then another issue for especially gateway providers is to deal with changes in the IP address in the home gateway. Java does not provide a standardized way to do this, and we defined a mechanism to basically cover this too. Resource monitoring, another big important specification, not just for smart home but IoT in general, because if you have a gateway, an embedded device that has limited capabilities, it has limited CPU, it has limited storage, you need to manage this environment, and this is what it's actually about. So we want to be able to monitor the consumption of a single bundle, we call a module, a single module, or a set of modules that are basically an application then in this case. And by monitoring this, we can actually take action, can say, okay, shut down this application, or restart it, or restart the whole software environment, for example. Device abstraction is currently one of the biggest topics in IoT, I would say, because it's about helping developers to integrate or to develop software for devices and not being expert in all the different protocols. So as a developer, as I mentioned before, you want to be able to serve many different ecosystems, but you also want to be able to use the same application for many different thermostats, for example. Whether they talk in ZigBee, in Bluetooth, or in other protocols shouldn't matter to you. And this is what it's all about. Well, we defined this device abstraction layer, and we defined also a set of generic functions, so that a developer can already get started. But there are lots of standardization activities about how to semantically describe smart home or IoT devices in general. This will take years until this is, let's say, finalized. But with this specification, people can get started and change it over the period of development. So taking the residential overall achievements of the residential expert group, so we delivered 2 specifications. We had a good collaboration with other organizations which were key for the adoption of OSGi in smart home, especially for telecommunication companies. The specifications that we produced are basically also applicable to many other IoT verticals. So then one more slide. So OSGi launched an IoT expert group in September 2015. That basically goes beyond just smart home. So we have about 12 OSGi member companies that are currently actively following this or participate in this effort. There are a couple of requirements documents that we started to collect. So one is about improving how to get access to devices. I mean, we have a specification that actually, when you plug a device into the gateway, that recognizes the device and that can automatically, install the necessary drivers. And we want to facilitate this process. Then we want to increase security for OSGi. So we will develop a testing platform for this. And if you're already active in IoT, you know the CoAP and MQTT protocols, and we basically are trying also to standardize APIs to interact with those devices. OSGi has a community event once per year, and we showed an IoT demo last year I think in November it was, where we had a Lego train, and where we basically allowed participants to develop new services for this demo. And this, let's say, was a huge success, and we'll keep doing this in the future. So before I finish, I would like to make a short advertisement. So as I employed by a process software, a German software company that was acquired by Bosch last year, we are, let's say, doing a couple of events around IoT. So March 8 and 9, we have the so-called Bosch Connected Experience event, which is a hackathon that is free of charge to attend. And we have 4 different challenges, so connected cars, connected sensors, connected manufacturing, and connected industrial services. And basically we invite people to, to attend this and to use, let's say, the different technologies that are provided by Bosch and partners like Salesforce and PTC to develop new IoT applications. Then another event that is just about the same time, March 9 and 10, is the Bosch Connected World, which is the IoT event of the Bosch Group. And we have about 16 speakers and 900 attendees. Among the speakers is also the CEO, Mr. Denner of the Bosch Group, as well as the CTO of KUKA, Mr. Schlögl. So it's a, let's say, a senior C-level, attendees meeting, if you want. So, and by this, I would like to thank you and close my presentation.